Hello everyone. Today is Unit 4, Day 13, Special Right Triangles. I will be able to use special right triangles to determine the side lengths of right triangles. So, there are two types of special right triangles that we're going to talk about today. The first is a 45, 45, 90 degree triangle, and the numbers 45, 45, and 90 relate to the angle measure of our triangles. So, when we have a right triangle that has angle measures of 45 degrees here, 45 degrees here, and 90 degrees here, we can use this pattern in order to determine the other side lengths. Similarly, if we have a 30, 60, 90 degree triangle, we can use these patterns in order to determine side lengths. Okay? So these are our two guide triangles that we're going to be using in order to determine the side lengths. So for our first teacher example, it asks us to find the value of the missing sides. In this case, we are looking for side lengths for D and E. When we have a 45, 45, 90 degree triangle, we know that this is an isosceles right triangle, which means two sides are going to be the same, which are going to be the sides opposite of our 45 degree angles. So if we look right here, this 8 is opposite the 45, and the D is opposite the 45. So we know that these two sides are congruent, and that E is our hypotenuse. Okay? Because of this information, we already know that D is going to equal 8. All right? But in case that's not the information that we were given from the get-go, I'm going to proceed as if we don't know that yet, okay? Now, step number 1 is to identify that we can use a 45, 45, 90 degree triangle, which we can because we have these angle measures 45, 45, and 90. And once we know that, we're going to draw the guide triangle, so this one right here, in the orientation that our problem is provided. So we're going to draw another triangle that looks like this. Here's my 90 degree, here's my 45, 45, my two congruent sides. And I'm going to label them with my A, and A square root of 2. So this one is my two sides that are going to be the same, and A square root of 2, which is opposite my hypotenuse, my 90 degree angle. Once I've drawn this guide triangle, I'm going to align and find the corresponding sides, right? So if we look at here, D and this A go together. Similarly, 8 and A go together. And lastly, our E here and our A square root 2 go together. So using those, I'm going to write 3 equations of your corresponding sides. D equals A, 8 equals A, and E equals A square root of 2. Looking at these 3 equations, you'll find that most of them have 2 variables, which we cannot solve, but one of them has only 1 variable. In that case, right here, A equals 8 is the equation that we can either solve or is already solved and therefore we can use. Here, A is equal to 8. Fantastic. We already have the equation solved, and all we need to do is anywhere we see the letter A, we can plug in the number 8. Which means D also equals 8, which we already knew from the beginning. And E is going to equal 8 times the square root of 2, where we're replacing the variable A with the number 8. Okay? Here, that tells us this variable D equals 8, and our variable E equals 8 square root 2. If we put 8 square root 2 into the calculator, you'll find that it is approximately equal to 11.3. All right. Go ahead and take a little bit of time and try student example 1 on your own. Now teacher example number 2. First, we can see that we have a 60-degree angle, a 90-degree angle, and based on what we know about the interior angle sums of triangles, this has to be 30 degrees because all 3 angles must equal 180 degrees. That tells us this is a 30, 60, 90-degree triangle. So, because we know that, we're going to draw our guide triangle in the orientation of our given problem. Okay? I know that my shortest side is represented by the letter A, and my hypotenuse here is represented by 2A, which leaves my longer leg equal to a square root of 3. From there, I'm going to find my corresponding sides. So here, K corresponds with A, J corresponds with a square root 3, 24 corresponds with 2A, and I can write my 3 equations. K equals A, J equals a square root 3, and 24 equals 2A. And again, we're going to look for which equation only has one variable. This 24 equals 2A has one variable. But A is not isolated yet, which means we need to solve this equation for A. In order to get A by itself, we're going to divide both sides by 2 and get A is equal to 12. Now, anywhere that we see the letter A, we can replace it with the number 12, which leaves us with K equaling 12 and J equal 12 square root 3. Now 12 square root 3 is approximately equal to 20.8. All right, so the value of K here is 12, and the value of J is 12 square root 3. Okay, go ahead and try the second student example on your own. All right, and we'll move on to the third example. Here, it says to determine the value of the missing side. So here we're looking for F and G. We see that this is a 90-degree angle, and we know that there are 2 angles that are congruent. Again, because we know that the interior angle sum of triangles must equal 180 degrees, we know that these both have to be 45 because it's the only number that is the same that adds up to 180 degrees, right? 45 plus 90 equals 180. Therefore, we can use the 45, 45, 90 degree guide triangle. So we're going to draw that guide triangle in the orientation of our given. And then write our 3 equations. So here 15 corresponds with a square root 2, F corresponds with A, and G corresponds with A. So we can write 15 equals a square root 2, F equals A, G equals A. Our first equation, 15 equals A root 2, is the one with only one variable. It is the one that we're going to solve. Now what's tricky here is it might look like an unfamiliar equation to solve, right? A times the square root of 2. But the square root of 2 is just a number, all right? A is being multiplied by the square root of 2. In order to get A by itself, we're going to do inverse operations and divide both sides by the square root of 2, canceling out and getting A by itself. So we know A is equal to 15 divided by the square root of 2, which if we put through the calculator, we'll find approximately equals 10.6. All right, So if that tells us A is approximately equal to 10.6, we can plug that value in for A here and A here, telling us both that F and G equals 10.6 units. Go ahead and try student example number 3 on your own. And don't forget to write your reflection.